delta R. So this and this is 90 degree. So by subtracting, we need this. So we need to subtract this angle, and this total is 180 degree. So 180 minus 90, this will be 90, and this difference is theta minus delta R, this angle, theta minus delta R. So these two will give you the angle. Verify yourself, this angle as this angle between IR and minus IAR as 90 minus delta R plus theta. Fine. Once this magnitude is known, IF0, let us take, this was IR, let us say this is IA0. This is the point corresponding to IF0, field current corresponding to IF0, corresponding to this magnitude. From OCC, we can get this EF, magnitude of no load EMF from OCC. This is the point at which this line intersect. Now once EF is known, voltage regulation can be evaluated as we know that VR, voltage regulation, is nothing but EF minus V upon V into 100%. So this was all about evaluation of voltage regulation using Potier triangle method or ZPF method. Fine. Finally, our ultimate aim is to get this EF, no load EMF, with the help of this Potier triangle. For that, we need to perform these two tests, open circuit test and zero power factor test, and we need to plot the corresponding curves OCC and ZPFC, and then corresponding to rated terminal voltage we need to draw a horizontal line which meets B, and corresponding to this length OA we need to mark this point C, and parallel to this AGL we need to draw a line from C which meets OCC at D. From D, draw a perpendicular which meets this line at E, and this triangle BED gives you Potier triangle. This is Potier triangle which gives two parameters. This is field current required to overcome armature reaction drop. This is field current. Okay, the second is leakage reactance drop, IXL. So from here we are getting XL. Once XL is known, substitute XL here, whether lagging or leading power factor, evaluate ER. Once ER is known, corresponding to ER, get IR. Once IR is known, this IR or this IR, we may get IF0. Fine. IAR is known from here, as already discussed, that this length BE represents the field current corresponding to armature reaction drop, that is IAR. Fine. So IR is known, IAR is known, and the angle between these two is known by evaluating delta R using this relation. Delta R is tan inverse this. So this is known. Once this is known, corresponding no load EMF is known from OCC, that's it. Just substitute this EF here, use this formula, get this value of voltage regulation. Let us quickly solve one very small problem based on Potier triangle. This problem was asked in GATE 2003. It says that curves X and Y, these curves, this curve was there in the exam, X and Y, in figure denote open circuit and full load zero power factor characteristic of a synchronous generator. right? OCC, this is OCC and this is ZPFC, the same OCC and ZPFC. Q is a point on the ZPFC characteristic. This is Q denoted in the figure itself. On ZPFC, at 1 per unit voltage, 1 per unit voltage means rated terminal voltage. The vertical distance PQ, this PQ in figure gives the voltage drop across. 4 options are there: synchronous reactance, magnetizing reactance, Potier reactance, leakage reactance. Yeah, quickly tell me, what is the answer? So this PQ, that is corresponding to this side of Potier triangle DE, and we know that this gives leakage reactance drop. So hope you have marked your answer in your mind as option D. Thank you very much. Try to understand each and every step. This method is not so easy, so don't expect that at first run, first watch you will be able to understand the method completely. But I hope if you will watch this lecture again and again, you will get the concept behind this method for obtaining voltage regulation. If still you have doubt, I am here, just drop a comment. I will try to solve your problem, answer your doubts. Thank you very much.